Hi guys, welcome to my channel subhassir'sclasses. Today we are going to go for the nomenclature part 2, and in this section we are going to describe in details the homologous series. First of all, let us discuss the nomenclature that we discussed in the earlier class. Every carbon compound, every organic compound has three parts as we discussed, the middle being the word root. The word root tells us about the number of carbon atoms, and for 1 we use meth, for 2 eth, for 3 prop, for 4 but, for 5 pent, and so on. We had already discussed. The last part is called the suffix part, because after something is suffix, before something is prefix. Both the prefix part and suffix part also further are divided into two. This is the primary suffix and this is the secondary suffix. Primary suffix contains the things about the double bonds, whether it is a single bond, double bond, or triple bond, while the secondary suffix talks about functional group, which may be an alkane, alkene, alkyne, alcohol, aldehyde, ketone, carboxylic acid, which is called alkanoic acid, so oic acid, and so on. So the prefix part is also divided into two parts. The part containing very close to word root will be the substituents, while the initial part, the first of the name, will contain the alphanumeric locants. Because they speak of the position, location. So alpha means alphabetic, numeric means numerical. So there may be a number like 2, 2, 3, 3, etc. So if there are 4 substituents, there will be a tetra. So the numeric ones are the numbers, the alphabetic ones are like di, tri, tetra, penta, etc., which represent 2 atoms, 2 substituents, 3 substituents, 4 or 5 substituents. And the substituents are like the atoms or group of atoms or ions which generally replace the hydrogen atom. So they will be like say halides, which are chlorides, bromides, iodides. They may be sometimes like oxo or keto group, or sometimes they can be nitro or something like that. So depending on these, the organic compounds can be named. So let us start with the first one, alkanes. This is generally the general formula will be RCH3 type. That must be, it must end with a CH3. The first one will be the alkane with only one carbon atom, so that will be called, this will be CH4, which is called methane. And this can also be written as HCH3. And every next one, since the general formula is CnH2n plus 2, so put n is equal to 1, you will have C1 H2 into 1 plus 2 H4. The next one will be ethane. There are 2 carbon atoms, so C2 hydrogen, number of hydrogen atoms will be 2 into 2 plus 2, so 6 C2H6, and that should be, the last one is CH3. So you can write H CH2 CH3 or simply CH3 CH3. The next one will be propane, because it will be an alkane with 3 carbon atoms, C3H8, 2 into 3 plus 2, 8, and this will be CH3, CH2, CH3. Next will be one CH2 more, CH3, CH2, CH2, CH3. Count them. There will be 4 carbon atoms, so C4. There are 3 plus 3, 6 plus 2, 8 plus 2, 10. So you try n is equal to 4 here. 2 into 4 plus 2 is 10, so C4H10. This will be 4 carbon atoms, so bute. There is a single bond everywhere, so N, butane. If we take the next one, we add CH2 more. There are 3 CH2 inside and there are CH3 at the end points. We have 5 carbon atoms, so C5. Clearly it will be 5 into 2 plus 2, that means 12, and this will be pentane. See, in all these we are adding, the CH2 is increasing, number of CH2 is increasing. So this is homologous series. Homologous means they have the same logo, ANE, but each one differs with a CH2. With each next element, with next member, we add one more CH2 to it. This is about alkanes. Let us go for alkenes. Alkenes is an unsaturated hydrocarbon and it must have a double bond. So the first double bond should be between 2 carbon atoms and the remaining positions are 4 positions. So alkenes start with 2 carbons, so that will be the first element will be having 2 carbon atoms, so ETH, and since there is a double bond, so ENE, ethene. So ethene will be H2C double bond CH2. Next one, we shall have a double bond as well as a single bond. So this carbon atom is having 2 places, this carbon is having 1 atom, so 1, 2, 3, 4. This carbon is having 1 here, so 3 more positions here. So if we add H here, we find this to be CH3, CH double bond CH2. See, the ethenes, the alkenes always end with CH2, while the alkanes ended with CH3. So this will be 3 carbon, so prop, and there is a double bond, so ENE, propene. The next one should be butene, 4 carbon. So you will add 1 CH2 here. Let us check if the compound also bears the same things. The double bond here, so there will be 2 hydrogen atoms, 1, 2, 3, 4. This carbon is tetracovalent, and this carbon is connected to another carbon, this to another carbon. Now 3 positions are covered, so the 4th position needs 1 H. This position will take 2 hydrogen atoms, this 3 atoms. So you get CH3, CH2, CH, CH2, CH3, CH2, CH, CH2, and this is also ending with CH2, and you see 1 more CH2 is added. The next one should add 1 more CH2. Which will be 1, 2, 3, 4, 5. So pent and a double bond, so ENE. See, there is a double bond here and 3 more atoms of carbon connected to it. This is having 2 positions, this is having 1, this is having 2, this is having 2, this is having 3. So CH3, CH2, CH2, CH double bond CH2. So you see the difference between butene and pentene is this was pentene. So in pentene and in butene, you see that there is 1 CH2 in butene, while there are 2 CH2 in pentene. So this is also homologous. Next, let us go for homologous in alkynes. in just in alkenes, one more thing I left, the general formula will be CnH2n. Let us check this. We have C2 here and there are 4 hydrogen atoms, so C2H4. In this there are 3 carbon atoms, C3, and there are 3 plus 1 plus 2, 6 hydrogen atoms, so C3H6, CnH2n. Here there are 4 carbon atoms and the number of hydrogen atoms are 3 plus 2 5 plus 1 6 plus 2 8. So C 4 into 2 8. Pentene, this should be C5H10. Look at here, C 1 2 3 4 5, so it is okay. And hydrogen 3 plus 2 plus 2 7 plus 1 8 plus 2 10. So this also obeys the same rule. Let us go for alkynes. In case of alkyne, the general formula is CnH2n minus 2. There must be a triple bond between 2 carbon atoms. So the first one starts with 2 carbon atoms, so ETH, and since there is a triple bond, YNE, ethine, and here there is a single position left, here there is a single position left. So the first member is HC triple bond CH. This is you see C2H2, and if N is 2, H should be 2 into 2 minus 2, that means 4 minus 2, that means 2. Next one is carbon triple bond carbon and one more carbon here, so a single hydrogen here. This carbon is already connected to 1 on this side, 3 on that side, so 4 complete. This one is having CH3, so CH3 C triple bond CH. You will find alkynes ending up with CH, alkenes with CH2, while alkanes with CH3. So the second one became C3, and this is prop.